So in this section, they talk about the different tests for finding first derivatives. For finding where you have maxima and minima for using the first derivative test, and testing for concavity. You know what that means, concavity? So we'll talk about that in a minute. But so from right here to here, this part of the graph is concave up, meaning it can hold water. And then from here to here, it's concave down. But we'll talk about that more when we get to points of inflection and stuff like that. So if you can see from this graph, you can have maxima and minima in a variety of ways. And you could have different things happening with the first derivative. And that first derivative doesn't necessarily tell you everything you have to know. For instance, here, first derivative is positive, curve is going uphill. Here the first derivative is 0, but that doesn't necessarily mean you have a maximum or minimum there. You could have a flat spot or a plateau, okay? Up here the derivative is 0, first derivative is positive, first derivative is negative, you're going downhill. Here you have a local minimum, then you're going uphill again. Then you could have something that looks like this, where you have a maximum even though the first derivative is undefined because the slope changes abruptly from one point to the other point. Then again, you're coming down here, flat spot, first derivative 0, but and then over here you have an endpoint. So at an endpoint you can have a local minimum down here. This is the lowest point in the whole graph, so that's your absolute minimum. And up here is the highest point in the graph. Even though the derivative is undefined, the function is defined there. So you could have absolute maximum at that point. So there's lots of stuff going on with the derivatives and different ways you could see them and stuff like that. And so this chapter kind of deals with looking at the first derivative, looking at the second derivative, and try to figure it from those things, trying to figure out what the original function looks like, okay? And so the first thing they talk about is called the first derivative test. First derivative test, and I already kind of showed you this already, but they put it into words. And they say at a critical point. So how do I find critical points? Anyone remember? You set the derivative is equal to 0 or undefined. Okay, so that's important. So the derivative is equal to 0 or undefined at a critical point. Okay. So the first rule says at critical point C, and I'll decipher what it means for you in a minute. If f prime changes sign from positive to negative to negative. I'm not going to write down every single thing that they write, because they say if it gets very confusing. For x is less than c and f prime is bigger than 0 for x is greater than c. And just if f prime changes sign from positive to negative as you move from left to right, okay? I'll just say left to right. This is in my own words, okay? From left to right, if the derivative changes sign from positive to negative, what do you have at that point C?
Max.
You have a relative or local maximum, okay? That's pretty easy, right? We talked about that, and we'll talk about how you test for that. So we'll do that later, okay? The second part says that if, it's just like this, if f prime changes sign, oh, that rhymes. If f prime changes sign from negative to positive, negative to positive, at the, just to say at C, from left to right again, as you move from left to right, left to right, and you have a what? And you have then there's a relative minimum, also known as a local minimum at C. Okay? And then the kind of a corollary to that is f prime, if you're at a critical point where the derivatives 0 are undefined, and if f prime does not change sign, from left to right, then what's got to be true? Left to right. It just means that there's no extrema there. This means it could be a plateau or it could be a point of inflection, but you just do not have a maximum or minimum. Yeah. Okay? And so if I put that there, so you could have something where so you could have, for instance, a place at C where the derivative, where it goes straight up, you know? Or you could have one where it's flat, as in y equals, that's not very good. The derivative would be defined there, but anyway. Uh-oh. It's doing that thing again. Come on.
Is he recording? Are you recording?
Yeah, I'm recording. At left endpoint, endpoint A, okay, we'll call it A. If f prime is less than 0, or f prime is greater than 0,
That's confusing.
or f prime is greater than 0, for x greater than a, then local min or slash max at if f prime is greater than 0. Okay, what should that say? Local min, local max. Local max, I think that should say.
Well, it's trying to show both.
If I know it's trying to say both. If f prime is less than 0, slope and downhill, and that would be a max versus a min at A. Let me make sure I wrote that down right. Because it helps to draw a picture of it. So if you're at some point A, right, here's point A. Probably don't have to put it right on there. So here's point A, right? I hear people packing up. So at point A, if the derivative is negative, what this says, if the derivative is negative anywhere after this point, what do I have at that point? I have it, so right, if it's going downhill, this point would have to be a local maximum.
But that's
right?
not true then if it's the, if that's the...
At the left end point, okay? At the left end point, if this is negative, then I have a local maximum as you move from left to right, right? Or as x, if for numbers bigger than a, if the derivative is negative, then that would be a local maximum. For numbers bigger than a, if the derivative is positive, meaning it's going uphill, then that point would have to be a local minimum. Okay? And the vice versa is true at B. At right endpoint B, okay? less than 0, or f prime is greater than 0 for x less than a, then, I mean, not a, less than b, then local, again, max slash min at b. Okay, so for instance, if I'm over here at point B on my graph, and if I go numbers less than b, right, if my derivative is positive, okay, meaning it's going uphill, I shouldn't have an arrow on there. If my derivative is positive, that means that I must have a maximum at that point, right? If I'm going uphill as I approach that point would have to be a maximum. If I'm coming downhill towards that point, that would mean that that point would have to be a minimum. If f prime is less than 0, yep, you're right. If f prime is less than 0, negative, then it's a low, yep, turns right. Okay? That should be a minimum and maximum. Okay? Minimum, maximum. So if the derivative is negative coming into that point's a minimum. If the derivative is positive coming into that point is a maximum. I guess that's about all we have.